Alright, today we're going to talk about 4 triangle congruence using side, 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 and side angle side. First thing we need to understand is the concept of triangle rigidity. And the triangle rigidity has to do with the length of the sides. So if the side lengths are known, then we say there's only one shape. That it could be. So if we know the lengths of the sides of a triangle, then there's only one shape that it could be, which allows us to segue into our first postulate from this section, the side, side, side congruence postulate. It says if 3 sides, so all the sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So what we can say is, when we look at this picture, I'll leave this up there so you can see it. We have 7 and 7, 6 and 6, and 4 and 4. Well, that means that we have 4 is congruent to 4, 7 is congruent to 7, and 6 is congruent to 6. The conclusion that we can draw is that triangle ABC is congruent to triangle. Now what goes with A? So it goes AB, so it goes D, F, E. Okay? So that's how this works. That's us saying that we are really just matching these things up. Okay, so that's the side, side, side congruence postulate. If 3 sides congruent to one, and if 3 sides in one are congruent to 3 sides in another, then we say that the triangles are congruent. So we're going to use side, side, side to prove triangle congruence. It says use side, side, side to explain why PQR is congruent to PSR. Well, here's what we know. We know that PQ is congruent to PS. We also know that QR is congruent to SR. And what we know from knowing all of this, that this is given by the picture and this is given by the picture. What we can also say is that PR is congruent to itself. Because notice, the 3 sides of this top triangle, of triangle number 1, are PQ, which is marked, and QR, which is marked, and PR, which is not marked. The 3 sides of triangle 2 are PS, SR, and PR, which is not marked. Well, PR is congruent to itself. So they already have these 2 sides with 1 hash mark, the same. They also have these 2 sides with 2 hash marks, the same. Well, PR is congruent to itself because of the reflexive property of congruence. And so because we say that, we know that all 3 sides are congruent to in one are congruent to 3 sides in another. So we would say by the side, side, side postulate, triangle PQR is congruent to triangle PSR. Okay? We're going to do the same thing down here. This would be a great time to pause and see if you can do this one on your own. I'm going to keep rolling through it. What we could say is AD is congruent to BC. Also, we could say that DC is congruent to AB because both of those things are given. And we could say that AC is congruent to AC by the reflexive property of congruence once again. So we make the conclusion that by the side, side, side postulate, triangle ABC is congruent to triangle CDA. Okay? That's as simple as it works. The trick right here comes in this step. This is the trick right here, knowing that we can say that a side is congruent to itself. The next concept we need to explore is the concept of the included angle. Now, an included angle is formed by two adjacent sides. Okay? So, for example, angle B is included between side AB and, don't want that to look like an E, CB. Okay? So B is the included angle because these two sides form it. So the two sides form the angle. Okay, so that's how that works. So when we talk about this next postulate, which, by the way, you should be putting in your cards to use on your test, this postulate is the side angle side postulate. It says if two sides and the included angle of one triangle are congruent to the two sides and the included angle of another triangle, then the sides are congruent. Think about it like this. Side, angle, side, side, angle, side. Matching game, guys. Congruent pieces. Side with 2 on it is congruent to side with 2 on it. Angle between, side with 1, side with 1. Okay, so the conclusion that we can make is that triangle ABC is congruent to triangle, oops, let me write them in the correct order. Since I started with A, which is the angle, I'm going to start with E. It's E, F, D. Okay? So that's how that works. Here's an engineering application. We're looking at the Statue of Liberty, and what I've done is I've zoomed in on this little piece here. So when I zoom in, this is what I get. These are the trusses inside the Statue of Liberty. You can see the torch up here, here's the crown, and here's the book she's got in her hand. So inside these trusses are made up of triangles, which is the strong kind of a thing. So we're going to use side angle sine to explain why KPN is congruent to LPM. Well, let's look at this. I have a side congruent to a side. So what I can say is this. I can say that MP is congruent to NP. So that's the side. And I can also say that side KP is congruent to side LP. Notice the triangles that I'm looking at are this one here and this one here. Okay, so this is going to be 1, this will be 2. Now, I could use side, side, side if I could find KN and ML. Unfortunately, they don't tell me anything about that, so I'm going to try to use side angle side, which means I need to say something about, let me get pink here. I need to be able to say something about this angle here. Conveniently, this is given, and this is given. But what I can say is that angle MPL is congruent to angle, so MPL is congruent to KPN. Except I need to know why. Because they're vertical angles. Okay? So because they're vertical angles, I can use the side angle side, side angle side postulate. So by SAS, triangle KPN is congruent to triangle LPM. Okay? So that's how this works. We're going to do one more example. You can try this one on your own. I'm going to roll right through it. Okay? I could say AB is congruent to BD because it's given. I can also say that angle ABC is congruent to angle DBC, and that's given. It's marked in the diagram. Side, angle, and I need to say something about this side. Well, I can say that BC is congruent to BC because that's the reflexive property of congruence. So by side, angle, side, triangle ABC is congruent to triangle DBC. It makes sense because I have a side, then the angle, then the side. So this angle is included between these two sides that are congruent. Okay? Now, two more examples. We're going to verify triangle congruence. Show that the triangles are congruent for the given value of the variable. We have stuff like this on the test. And it's saying this is what x is. So prove that these two are congruent. It looks like that I'm going to use side, side, side. I'm going to put a question mark by it because I have the three sides. I don't have any angles. So what I'm trying to show that all of these sides are the same. Okay? So now, unfortunately, I've marked all of these with U, but that's not correct. So what I'm going to do is this. I need to show that 2 goes with this one. I need to show that 3 goes with this one. And I need to show that 4 goes with this one. Okay? So, I'm going to put 4, a question mark. Is it equal to 3 times 3 minus 5? Well, it's 9 minus 5. 4 equals 4. So what I can do is I can mark this with 1, tick mark, because I tested this side. It's equal to 4. Now, if this is x, then x is going to be 3. Does 3 go with 3? Yes. So I can mark this side, congruent to this side, and x minus 1 would be equal to 2. So is 2 congruent to 2? Yes. So I can say by side, 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 the two triangles are congruent. Okay? It's keeping us from needing to prove 6 things. We don't need to prove something about the angles because we know that triangle rigidity tells us that if they have the same side lengths, they must be the same shape, same size. Okay? Here's one that you can do. It involves an angle. So what I'm going to do is I'm going to say, give you the suggestion to say, what does that mean? I need to put in one extra piece of information that I seem to have left out. My mistake. That should be 126 in there. Okay? So 126 degrees right there. I'm going to keep rolling through. I'm going to plug it in. So what I need to be able to show is that 2y minus 1 would be 2 times 7 plus 1, which would be 15. So 15 and 15 go together. So I've got a side, congruent. Y squared would be 49 minus 4 times 7 plus 3. 49 minus 28 would be 21. Plus 3 would be 24. 24 is equal to 24, so this side is congruent to this side. And this is going to be 12 times 7 plus 42, which is 84 plus 42, which is 126. So the angle is the same. So I can say by side, angle, side, triangle DEF is congruent to triangle JHG. Look at this. Side, included angle, side. It goes in order. Notice I'm not skipping around. Side, angle, side. So I go 1, then angle, then 2. 1, then angle, then 2. Side, angle, side. These two triangles are congruent. It keeps us, notice I didn't use this angle H, I didn't use F, because I'm showing that that's enough information to be able to prove that they're congruent. Okay guys, thanks for watching. We'll see you next time.